Imagine a weapon that can see its target, adapt its flight, and strike with incredible precision. That's the modern missile. But how do these incredible machines find their mark, often miles away, traveling at supersonic speeds? The answer lies in two critical technologies: radar guidance and thermal imaging. Let's start with radar guidance. Just like a bat uses echolocation, radar uses electromagnetic waves to detect objects. A radar system sends out these waves, and when they bounce off a target, they return, revealing the target's position, speed, and direction. Before a missile can hit a target, the radar system has to find it first. This is called search mode. In this mode, the radar sweeps a wide cone of electromagnetic waves across the sky, painting a picture of everything out there. When the radio waves reflect off a target, they show up on a display as a simple blip or a brick. At this stage, the radar isn't focused on any one target, it's just looking for anything. Once a potential target is detected, the pilot or operator can command the radar to enter track mode, also known as lock-on. This is a critical step. The radar stops its wide sweep and focuses its entire energy on that single target. Locking on allows the radar to get a much more precise and rapid flow of data. It continuously calculates the target's position, speed, and direction, providing a real-time solution for where the missile needs to go. For semi-active missiles, this is where the missile's seeker head would begin to see the reflected energy and use it for guidance. For active radar missiles, the lock-on data from the launch platform gives the missile its initial flight path and allows it to go active and take over its own tracking later in flight. But the journey from launch to impact is where the real magic happens. The missile's specific guidance system, chosen for the mission, is now ready to execute its part of the plan. And there are a few clever ways it does this. First, active radar homing. Think of this as the missile having its own eyes. It carries a small radar system right on board. Once launched, it sends out its own radar waves, tracks the reflections from the target, and guides itself autonomously. This is a fire and forget system. The missile does all the work, freeing the launching platform. It's perfect for the final stages of an engagement. Then we have semi-active radar homing, or SARH. Here the missile doesn't emit its own radar. Instead, it's a passive receiver, like an ear listening for reflections. A separate platform, perhaps a fighter jet or a ground station, continuously illuminates the target with its powerful radar. The missile simply homes in on those reflected waves. The catch? The illuminating platform must keep tracking the target until the missile hits. But what if the enemy is trying to jam your radar, or you need to be stealthy? That's where thermal imaging or infrared guidance comes in. Everything above absolute zero emits infrared radiation. In simpler terms, everything gives off heat. Missiles with thermal seekers act like highly sensitive heat cameras, detecting these invisible heat signatures. Think of a jet engine's fiery exhaust, or the warm skin of an aircraft flying at high speeds. These are beacons for an infrared missile. Older infrared systems were fairly basic. They'd simply home in on the strongest heat source. This made them vulnerable to countermeasures like flares, which are essentially super hot distractions, drawing the missile away from the real target. But modern systems are far more sophisticated. These are imaging infrared, or IIR, seekers. Instead of just sensing a hot spot, they create a full thermal image of the target, much like a digital camera. Onboard computers analyze this image, looking at the target's shape, its heat distribution, and even distinguishing it from the background. This allows them to ignore simple flares and lock onto the actual aircraft, even identifying specific types of targets based on their unique thermal signatures. They are incredibly resistant to jamming and countermeasures, making them very effective in combat. So, whether it's through the unseen waves of radar or the invisible glow of heat, modern missiles are equipped with incredibly advanced senses to find and engage their targets. From fire and forget autonomy to precision heat seeking, these technologies continue to evolve. making the battlefield a complex interplay of detection and evasion.